So, as part of our 20th anniversary celebrations in 2024, Pharos Architectural Controls is spotlighting 20 people and projects that have helped shape our company and our products and continue to inspire us every day. Michael Gross from Pharos and I are really excited today to be joined by Robert Bell from Pathway Connectivity and Alan McIntosh from Mulvey and Bonani to talk about their respective roles on the world famous Niagara Falls and how Pharos Kit continues to bring the incredible brief to life. Hi everyone, it's lovely to have you on the podcast again. You're returning guests.
Yes, thank you for having us. This is amazing. Love it.
Yeah, it's awesome to have you. And obviously, we're going to dig straight into talking about Niagara Falls, an absolutely sort of world-renowned project and landmark for so many. But tell us a little bit, Alan, about your kind of first touch point with the project from a lighting perspective and what that brief actually looks like.
Yeah, the history of Niagara Falls goes back a very long time. Our role in it was we were the lighting designers or the lighting consultants for a consortium or a collective of companies that were pursuing the project. Ourselves, a manufacturer's rep, and controls contractor and representative. We all teamed up with an electrical contractor and became sort of like a design build type of project. So there were teams that were built, and they all pursued the project individually. And there were a series of landmark tests and presentations that they needed to pass. And if you passed, your envelope went on to the next round. And if you weren't successful in that round, they shredded it. So we were successful, obviously, in the entire process. But what we were able to learn from a very early stage was just how rich the history was of Niagara Falls and the illumination of it starting in the 1800s. Somebody observed the falls being illuminated periodically during a thunderstorm, and every time the lightning flashed, they saw the falls. It used to be in darkness. So the first illumination of the falls was in 1860, and it was to honor the Prince of Wales Edward's visit, and they launched 200 Bengal flares into the air to honor his visit, and that was the first time the falls was illuminated intentionally. And then go flash forward. The first time it was lit electrically was in 1879, using carbon arc fixtures to celebrate the Governor General's visit to Canada. 1907 was the first time they had an installation of carbon arc fixtures that illuminated the American Falls. So in the falls, there's what everybody calls the American Falls, which is sort of that straight falls, and then there's the Horseshoe Falls, which is sort of known as the Canadian Horseshoe Falls, and that's the one that sort of you see in all of the pictures that wraps around the gorge. And in 1925, they installed about 24 carbon arc searchlights on top of the power generation surge tank, which is now known as the illumination tower. And those carbon arc searchlights were then sent over periodically. It's not periodically. They were sent over to England during the World War because they were used to search the skies for enemy aircraft. And then once the war was over, they were sent back and installed on the illumination tower permanently. In 1958, there was a upgrade from carbon arc, to new carbon arc, and in 1974, the luminaires were retrofitted with xenon. So that is a rich history. And then before 1974, there was nothing done until 2015 when we switched it to LED.
And with the xenon, they had massive semaphores for gel.
Yes,
that
yeah,
burnt up every
they had
night.
retrofitted giant cabinets, and there would be a push button, there still is an operator there. It's all manned by person, and before Cinegel they would click it and it would drop a sheet down, so it was only single colors at a time, and they had the ability to lower individual colors in front of the xenon lights. And I mean, they had to replace them fairly regularly because they'd only last an evening or two, just because of the sheer heat. But so when we got involved, the intent was to improve the illumination of the falls with newer technology, and we had to the tests became a little bit more difficult. We had proof of concept, we had proof of all of these sorts of things, and then it all culminated at the end with a mock-up test. So we needed to provide double the amount of light. They were going to, for the mock-up, they were going to turn on one of their xenon lights and point it at a location, take a measurement of the center of the beam, and then whatever that center beam level was, when we turned on our mock-up, we needed to double that or even more. So we got to the mock-up, and we had done some tests, and we understood that the center of the beam was probably about 6-foot candles at 2,100 feet. So our target through the entire process was 12-foot candles or higher. So when we did an airport, we visited an airport in Niagara region and measured out 2,100 feet and turned on our sample lights and took measurements. We went to a marina north of Toronto in Innisfil Barrie area, and measured out a dock on the other side that was about 2,100 feet away. And that's where we had each individual module. So our goal was to always to provide, we were always thinking of color. The RFP only stated that we were to double the amount of light in white light. But we always had this idea of wanting color because they had the Cinegels, they had everything, and we wanted to continue that. And there's always that attraction of color and dynamicy to the installation. So we had each white, a red, a green, and a blue module, and we took measurements 2,100 feet away to get an idea of what level of light that module was providing at the other side. And I mean, at 2,100 feet in complete darkness, you're like you're very minimal. And then we took those numbers and calculated how many we were going to need, how many white we were going to need to create 12 to 14 foot candles. And that number was 74. And then what we were able to do was we took the levels that we were getting from red, green, and blue, and calculated how many of those red, green, and blue we needed to replace one white. And then we started taking white modules out of our mock-up and putting in color, so that when we turned everything on, it was producing white light and we could get that level across the gorge. But then we also had the added ability of turning off the white and demonstrating color technology, the color from the LED. So on the night of the mock-up, we set up this gigantic thing that was transported by a glass truck. So it was driving down the QEW with this thing on the side of the truck. We set it up and we aimed it. They turned on their xenon fixture that night, and it was getting about 6.5 foot candles 2,100 feet away. We turned on ours and we got 14 foot candles 2,100 feet away. And then we started demonstrating color, and I think our mock-up was supposed to be a half an hour, but the illumination board kept us there playing with our mock-up for about an hour and a half. They were impressed. They were blown away. The whole RFP process it was based on they didn't know whether there was anything out there. So they put out this RFP not expecting or trying to get an idea of what was available on the market, what was available at that time to replace old technology with newer technology and give them a power savings, a cost savings, all of that sort of thing. But so when we turned it on, I don't know if they weren't expecting anybody to succeed, but they were surprised that we did. And they were surprised at that. So we took that technology and okay, hold on one second. I'm going to pause here for a second because I can talk a lot longer and I don't want to. I don't want to. I'm being cognizant of time.
No, it's absolutely fascinating, and it's fascinating to hear. You gave us that kind of whistle stop history of the kind of the first lighting kind of installations, as rudimentary as they were, right up to the point where you can show what like modern day technology can do for for the falls, and how that can enhance visitor experience, and just kind of make it the incredible landmark that it is. I mean, I suppose bringing you in, Robert, like when did you become part of the project, and what was your role on the project?
Well, the obvious thing now, but it wasn't so much at the time, was that it was going to become DMX. When you're turning on, they were 10K xenons, right, with semaphores. And none of that. It was all manual control channels, right? Just analog and switches, turn it on. Not just switches, but the ballast. So what Mulvey and Benanti was suggesting with this new technology was, a xenon lamp was, about $2,000 or something to replace, and they had to replace them every month and a half, every 2 months. And it's also very dangerous. You have to suit up, and so there's a lot of maintenance, a lot of cost to it. The efficacy of xenon compared to LEDs, the electricity savings, Alan, you could probably quote numbers, but you're getting twice as many foot candles with the ability to do rapid changes of color, which is impossible with semaphores. And you're not changing light bulbs all the time. You don't have this heat building problems. You don't have the humidity. The ballast hated. I mean, the place where the ballast was stored, it was dripping wet, and it was concrete and cinder block and ugly and wet, and there was all kinds of maintenance problems and spiders and everything. So what was being offered was unbelievable, and to drive it was going to be for the first time DMX instead of all these analog and literally people throwing switches. So they came to Pathway because we're known for doing large networks, and we're also talking 3 different lighting locations. So we're talking it's longer than a DMX cable. So it was requiring fiber to get from the lighting tower down to the bunker, which lights the American Falls straight across the river. A lot of the lights were actually in the lighting tower, close to where the Pharos controller is. But then there was way upstream, there's a restaurant called Table Rock. And this was brand new. This had not been done. This came out of Mulvey and Benanti's lighting design, was to have an additional bank of lights that were shooting at quite an oblique angle to get in. But the problem is with the Horseshoe Falls, you got water coming in from every direction. So, and it hits pretty deep water. So you get this massive plume of mist that rises 3 times the height of the falls. So if you're shooting to the back of the horseshoe, you're shooting through a huge amount of vapor in the air, and all you're doing is lighting up the vapor, and nothing gets lit at the back. And one of the most thrilling things, if you go visit the falls, is to stand on the Canadian side right at the precipice, like you're feet away, where you're seeing 1.5 feet, 2 feet of water going right over the edge. And from that vantage point, you can actually see the back of the horseshoe. And it was never lit before. It just went off into darkness. So to do that, you needed to have control, get to that very, very remote location to get those lights to get in behind. And that required fiber. And that's where our via Ethernet technology came into play. And most exciting for myself, who does a great amount of the programming of the Pharos control system, is the connectivity to the Pharos cloud. So not only the Pharos controller is on the cloud, which means sitting in this chair right here, I can get to it, I can trigger it, and I can upload new artwork to it and all the rest of it. But also all of the pathway connectivity gear is part of the Pharos cloud, or the 6i cloud, one and the same. And I can see all of our path ports, I can see all of our vias, I can see link status of all of the connected ports together, how long they've been up. I can reboot things remotely. I can dig deep right into a path port and say, never mind what the Pharos is doing, never mind what the backup vignettes are doing, never mind what's happening to the fiber between this location and that location. I actually want to get right to the DMX port and see the values coming out of it. And all of that sort of stuff is available with the 6i cloud. And it's remarkable. I can right here with my mouse right now, I can actually go and open and close the garage doors. I can see what levels are coming out of it. I can see how long the Pharos has been up. I can see, how many power over Ethernet watts are being used. It's just, I could do an RDM discover and find all of the drivers. There's 1,400 drivers.
There are 1,400, drivers, and we were so the old lighting provided 21 zones because it was just xenon pointed straight at the falls, and it was
Blotch, blotch, blotch.
it was blotchy, so it was an intense level of light because the beam was so narrow. There was an intense level of light and then nothing around. So the uniformity was insanely off. Like it was intense and then nothing. So like the levels we were dealing with at the very beginning were 3-foot candles, like 6-foot candles in the center, and then trailing off to 0. And what we were able to do, knowing that we needed to increase and double the amount of light from the center with our mock-up, afterwards, what we were able to do was convince them that you don't need 12 to 14-foot candles of light across Niagara Falls because you're going to burn people's eyes out. And what we were able to do was show them through scenarios and mock-ups and tests that if we maintained that 6-7-foot candle but created a more uniform illumination of the falls, that would then be perceived 3 to 4 times brighter because your eye isn't seeing the light and the dark, you're seeing a blanket of light. And then with the modules that we were using, the Stanley modules that we were using, on average, they're about 30 watts if everything was on. But we were able to save Niagara Parks through the dynamic color changing abilities. On average, they're saving 80% power from what they were previously. Their power consumption.
When you're adding red light, you're
Yeah,
just adding red light. You're not having to filter out
exactly.
every other color in the rainbow.
Yeah,
but
because
the heat.
what we're doing is that we're not using a module that has red, green, and blue within it. We actually have a red module, a blue module, a green module, and a white module. And they are all mounted into a nice enclosure that has heat traced glass so that the ice melts. But all of those modules are calibrated to a single point that they're all on torsion screws. So we were able to aim them to a single point and then mount them so that when they shine across the falls, they're all like 2-degree beams. But when they get to that other side, the pool of light is between 50 to 65 feet wide. And what we were able to do was cascade them and build them. So the ones on the bottom are aimed to the top and the ones on the top are aimed to the bottom so that we don't break the crest of the falls. But with the ability and the resolution of each one being controlled individually by the DMX driver, we were able to create within that one unit, we were able to create two or four. We created basically four DMX addresses or what's the word? I'm blanking. But
Zones.
each row is a zone within within the unit. So we have the ability, the ones that are aimed at the bottom over they lay over, and there's some blending between the top row and the bottom row. And because we have the ability to control each row and each module separately, we went from 21 zones of control to almost 300 zones of control, because we have the ability to now do gradients down the falls and have because what we were finding when we did our tests was if we just did the units, it became very blotchy. So then we broke out the addressing and the zones so that each row of that unit now can fade between the other ones.
And this is where Pharos came back into play.
Yeah.
And MG, maybe you could speak about the custom interface that Pharos built for the operators to do, so we could make flags and banners. And
so that's what I was just going to mention, based on what Ellen was describing with the increase in the resolution with the system. I mean, I like to say, when people see pictures of it, it's almost like they're painting on the falls. It's insane, like the level of like resolution. But so during the project, you guys had reached out to us, and along with the control system and the cloud, one of the other things we're able to offer you was basically a custom user interface, right, to control this. And so we're like, yeah, sure, no problem. But then you were like, okay, well, we'd like actually two, because we want a separate one for the US side, and then we want another one for the Canadian side. And we're going to have different programming on this side and different programming on this side, and some of them match up, but I want a common interface and whatever. So it was really interesting to create a nice graphical, easy to use custom interface for this landmark project. But just I noticed as we were making some of the buttons and some of the thumbnails for things, I'm like, can't even believe this can do this. Like, it was just like, you know what I mean? Because most things, it's like, oh, here's a couple colors, here's like a 2-color gradient or thing. But it was like, no, here's this like detailed, photograph of a thing, that's going to go on the falls. And you're like, okay. Like, so it was pretty wild, like,
And the operators get requests from the Niagara Parks Commission and the Illumination Board on special nights. So it's very easy, because of the way that the lighting design was done with this resolution. There's the American Falls is a nicer palette because there's not that big plume of mist, but it's mirrored on both. But there's like 4 rows horizontal from left to right, and there's like 5 columns. So with that, you can do like, a Spanish flag, an Italian flag, an Irish flag, very easily, a Canadian flag, very easily. But we even do the American flag, where you can do like a white stripe, a red stripe, a white stripe, and a red stripe, and then a blue blotch up in the top left. And people get it. They can see that. And the operators have the ability. They're not theatrical programmers. They're the tourist front of house people that speak to the customers, but they get a phone call and say, oh, can we put the Ukrainian flag up? Okay, yep, row this, that color, and they color pick it. So that's that. But there's also the ability for the hotels or the whoever to invite VIPs to actually come. So not only did Pharos create these big touchscreen interfaces with resolution and control, but there's 2 iPads that sit out on the deck at the Illumination Tower, one for the American Falls and one for the Canadian Falls. And when the VIPs come, they can actually press the button themselves and make it do something. But for that interface, they wanted a very, very limited palette of what they could do. They're allowed to pick 6 different colors. What's your favorite color? Blue. Okay, it's not like, azure blue or diamond blue or surprise pink or whatever it is. You get blue, you get green, you get yellow, and they press it, and then the Pharos control system automatically within 20 seconds after they do the selfie with themselves reverts back to something else. And they just have to keep moving these people through, because if you gave them the full palette of control, you would never get them out of there.
Oh yeah, they'd be there forever. Yeah.
Yeah. So
that's amazing. I mean, it's such a phenomenal kind of wonder of the world anyway, and then to kind of overlay that level of technology and that level of expertise to be able to maximize it for its absolute, to its potential. I mean, I guess we could probably spend a whole other podcast talking about, where the limit is to to what else could be done and what the future holds for Niagara Falls with with technology just kind of going skywards, the way that Pharos controls and sort of evolving, and how your kind of
I'll touch on that just a tiny bit, Amy. One of the things that the LPC is great for is that it's timeline based, and you can add audio to it and synchronize it. So on occasion, there's been events like Monday Night Football was one where the Buffalo Bills were hosting, and they came and they did the opening of the show there, and I programmed specifically for them to the theme song of Monday Night Football. And then they shot that obviously without speakers there, but then in post put it together, synchronize it. I just did like a clapper board so that the camera could sync up with the audio, and then in post they did it. So the opening of the thing was a whole bunch of fans standing watching this, and you could do that when you have that much control, and then you synchronize it to music, which is something we hope we do, kind of like they do outside of Bellagio at in Vegas. The fountains are synchronized to music. We would love to do that sort of thing, and Pharos is just sitting there eager to do it because that's exactly what it's very, very good at. So
yeah, that's it. It's that blending, and kind of it takes us full circle to the beginning of the project where we were talking about that fusion of architecture and entertainment, and that's exactly what we've kind of got here, isn't it? It's just we could spend the same time again and more to talking about this project, and it's been absolutely fascinating. So thank you both so much, and MG2 for for your time to kind of delve into it, and we've really been enjoying the pictures that we've been showing on screen as you've been talking as well. It's phenomenal. So keep doing what you're doing, and we'll keep wondering, looking on with wonder at Niagara Falls. What an incredible project.
If anybody wants to hear more, I could literally talk for hours. So if you see me,
I feel another podcast coming on.
Yeah.
Well, congratulations, Pharos, for 20 years. Can't wait to see what's coming next.
Yeah, thank you so much. It's been great to have you, like I say, returning guests, and we've been thrilled to share this campaign with you.
It's been our pleasure, and
Take care.
have a good one.